All right, so let's move on to potential. So the definition is it's the work done per unit charge. That's the definition for potential. It's the work done for unit charge to bring a positive test charge from infinity to a certain distance. Okay, let's break this down. So this is the definition of it. So what does that mean? So it's the work done to bring a charge from infinity to R, but it's work done per unit charge, right? Per charge. So this is the definition of V, which means what is work done? Work done is force times distance, right? Some distance dl. You can call it dx or dl. Let's make it 3 dimensions, so dl. From infinity to r per unit charge, like this. All right, so if you have a point charge like this, of charge, let's say q. So how do I find the potential at this point? So let's find the potential at this point. So what you need to do is imagine you have a little test charge, Q test, okay, I will call it Q test, to bring it from somewhere from infinity all the way to here. Okay, how much work do you need? So you calculate that and divide by Q. So what is the force that it feels? Well, there's Q over here, so it'll feel a force that is KQ Q over distance. Let's say this is R, but this is somewhere over here. So let's say this whole distance is X, let's call it. So that's the force, all right? So the V is from infinity to R, KQQ over X squared. And I want to move it from here to here. Okay, so I'm moving it this way. So a little bit, so if I'm calling this X, moving it a little bit this way, it's dx. So let's pull out everything that is a constant. In fact, this q cancels, so you have kq. Yeah, that's all you can pull out from infinity to r, and then you have 1 over x squared dx. Integrating this raises it from -2 to -1, and you multiply by -1 as well. And then from infinity to r, you plug that in, so you have kq over r minus, sorry, there's a minus sign in front of everything, this definition. And minus plug in infinity, so 1 over infinity, so that's 0. So you have kq over r. So this is a very useful formula for point charges. All right, so at this point, the v is kq over r. How about if you have 2 charges? So if you have q1, q2, and you want to find the potential over here. So now you can just do it the easy way. You can just add up things because you know that it is a scalar and you can add up scalars. So the total is the v due to 1 and the v due to 2. The v due to 1 is kq1 plus over this distance, r1. And let's call this d. So v2, what is v2? It's kq2 this time, but I need the distance from here to here, right? So it's r1 plus d, for example. And if you have a third charge like this, then you need to find the distance, r3, sorry, q3, r3, and the total will just keep adding up everything. So you just need to find the distance and then use this formula. So if it's a point charge, you can always just use the q of the point charge divided by the distance from the point of interest to your charge. Okay? Very useful formula to recite it as well.